Hello. So this is a puzzle by the setter fritzdis, um, and it has a monster of a rule set. So I've been playing around with between lines in my own setting, and I've been, as a result, looking at a lot of between line puzzles. So I couldn't resist this when it popped up as a testing request. This is called the Tilted Crown. It is a minimal between line clone skyscraper Sudoku. So minimal between lines, I don't know if they're like an invention of fritzdis's own, or if they're something that exists kind of in the wild. I've never seen it before, but what it means apparently is that between lines have to have their digits and the bulbs on the end. So all the digits along the line have to be strictly between the digits and the bulbs on the ends. So like these have to be between this and this. But in a minimal between line, those digits have to be as close to each other as possible. So for example, here, this couldn't be like 1 and 9 because you don't need them to be that far apart. They could only be, 1 and 4 because we could put like 2 and 3 there, or maybe 3 and 6 because we could put 4 and 5 there. But it couldn't be, 3 and 7, even though it's not turning red. It couldn't be 3 and 7 under Fritzditz's rule set because that's not maximally close together because there's extra like wiggle room there. So basically the between lines need to be as close, need to have the difference as close as possible as allowed by normal Sudoku rules. Clones, these two 4x4 regions, have to be identical to each other in terms of digits entered. And skyscrapers, uh, I'm not gonna lie, I don't really care for skyscraper Sudoku. I'm sorry, Fritz, it's just not my cup of tea. It doesn't wet my whistle. What it means, though, is that you've got these numbers outside of the grid, and if you imagine that each number in the grid is a skyscraper, and taller skyscrapers can be seen over the top of lower ones, but shorter ones can't be seen over the top of taller ones. So, like, if you've got skyscrapers like this, like a height 8 and then a height 5, you can see the 8 from this direction, but you can't see the 5 over it because it's shorter. But then if you put a 9 here, we'd be able to see the 8 and the 9 because the 9 is even taller. And like if we put a 3 here, we'd also be able to see the 3 because it's short, but it's in the front. And then these digits on the outside, these 3s, all that means is that from any of those directions, looking straight across the grid, you would be able to see 3 skyscrapers exactly, given those rules about skyscrapers. So that's where we're at. Let's try it. I'm just glad it's not a disjoint puzzle like the last one. So, I'm really interested in this minimal between lines kind of situation. Now, the first thing that stands out to me is this and its clone. Because what strikes me as just deeply weird and exciting is that in this arrangement, so these orange cells have to be exactly the same because they're in the same positions in two clones. Up here, these 3 cells are between these, but down here, these 2 outer cells are actually part of a between line going between the inner cell and something else. And that seems like, I can't puzzle out exactly what digits that implies now, but I do want to make a note of that because I feel like that's going to turn out to be fairly restrictive. So there's that. That's kind of cool. What else can we do right now? No given digits, unfortunately, tragically. Nah, I love no givens. I think that's a great rule set. Um, One thing that does strike me is maybe where could we place a 9 in this box? It definitely can't be here, 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 because that's on a between line. You can never place a 9 on a between line because it's not between any 2 other digits. I guess we could place a 9 here because like if the skyscrapers went, I don't know, like 1, 2, 9, that would be fine. That would let us see 3 skyscrapers in total. So we can ignore that for now. Maybe we could do something with 1s and 9s in the clones. Okay, that's my first thought. So here, the digits in the clones that are on between lines are these ones marked in blue. Therefore, because they're on between lines, they can't be 1 or 9. So those can't be 1 or 9 either in the other clone. These are on a between line in the upper clone, so those can't be 1 or 9, which means that these can't be 1 or 9 in the lower clone. Oh, that's just too cool. So none of these digits can be 1s or 9s in either of these, which means that these have to be at least 2 and at most 8. Now, they can't be 2 and 8 because that wouldn't be a minimal between line. Like 2 and 8, there's more than 3 digits in between there, so it's not minimal. It could be, though, 2, 3, 4, 5, 6, and that would be fine. So that does imply that one end of this between line has to be 2, 3, or 4, and the other end has to be 6, 7, or 8. And I don't know which one is which. And that also implies that I can pencil mark these. That also means that these 3 digits have to be strictly between 2 and 8 at the very least. So they can only be 3, 4, 5, 6, or 7. Anything else I can do with that right now? Nope, let's go somewhere else. So where do we want to go then? I'm not super experienced with skyscrapers. Luckily, it doesn't look like there's a ton of skyscraper clues here, so I'm just literally going to ignore those for now. Maybe we'll focus on some of the minimal between lines. I mean, this between line has 3 in between, or 2 in between. That's kind of interesting because in a minimal between line that's that short, you're almost dealing with Kropke. Like, this number and this number can only be 3 apart. And if they're called x and y, and like x is the lower one, y is the higher one, then your 2 digits in here have to be x plus 1, x plus 2, also known as y minus 1 and y minus 2. Like, you have to have kind of 4 consecutive digits going in there. And that's kind of interesting. This can only be 3, 4, 5, 6, or 7. I don't think any of those can be ruled out. This is a very, very interesting rule, though, minimal between lines. It really, I guess these 5 have to be consecutive as well. Not in order, except that one of these is the biggest one and one of them is the smallest one. But in some sense, they have to be consecutive. That does mean that one of these has to contain a 5, because no matter what 3 consecutive numbers you use in the range 3, 4, 5, 6, 7, you'll always end up with a 5. That means one of these has to be a 5. Okay. It's almost like an out of order consecutive sets kind of puzzle is essentially what we're playing with here. So how about this? The minimal constraint for this between line would actually be satisfied if these were only 4 apart. Because even though these 3 have to be different, technically this could be the same as one of these 3, and in fact in this rule set, because it's minimal, this has to be the same as one of these 3. Specifically, this digit has to be the same as one of these 2. And then these will have to be exactly 4 apart. And then, of course, this digit is the same as something up here. Same with this, because this is just kind of symmetrical. This digit has to be the same as one of these 2. And in turn has to be the same as one of these. There's a lot of symmetry here. I guess we have to figure out what's going on with the between lines and the clones. I think clones plus between lines is a really interesting combination. So suppose that this is the low end. Like, let's just suppose for the sake of argument that this is the low end and this is the high end. So I'm going to mark the high end in orange and the low end in blue, and I'm going to clear all of my other highlighting. That would mean that this is lower than everything in this wiggle. Well, that would mean there's a digit on this between line that's lower than one of its endpoints, meaning that in this between line, this would have to be the high end. And this would have to be higher than this, which would mean in this between line, this would have to be the low end, making this the high end. So in other words, you almost have like an imaginary longer between line here, where, and if of course, if this was the low end and this was the high end, all of this would simply be reversed, but the relationships would be exactly the same because we've only worked with things that are totally symmetrical in this puzzle so far. So that means that no matter what, in these two between lines, there's one low end and one high end between these two. So one of these between lines goes up and then the other one goes down. Now, essentially, like that's really going to limit the numbers we can actually use, because let's just keep working with this supposition that this is the high end, this is the low end. Well, that would mean that this has to be at least 4, and this has to be at most 6. And on top of that, these have to be within 2 of each other, because these have to be clustered close together in order to fit on this between line. So that means that, like, one potential scenario would be like 1, 2, and 3, 4. And now all 5 of these have to be different from each other, so we can't repeat a 4. I could go like 2 and 3 there, and then repeat a 3. Yeah, so then the lowest we could go there would be 3, and then this would have to be 5 and 4, 6. And now that's actually impossible, because now these couldn't be the ends of this between line because they're not far enough apart from each other. 2 and 5 can't be the ends of this between line. Ooh, that is absolutely fascinating. So what does this mean? Wow, what an intriguing, like kind of intricate little setup. So these two cells are equivalent to the ends of the between line in the top right clone. And that means that those two cells have to be exactly 4 apart from each other. And these 3 have to be the numbers that are between them. These 2 have to be at most 2 apart from each other. So these are either 1 or 2 apart. And this is at most 2 apart from this. Does that mean that this has to be strictly higher than that? I actually think it might. I'm not totally sure, but it might. So here's what happens if we make this end, and again, we're just working under symmetry here, so whatever, it's fine. Um, if this end, let's say this end is lower than this end. So suppose that that's a 3, and then this is higher than 3. Well, because these are all clustered together, this has to be either a 4 or 5, because it has to be pretty close to the 3, because in this clone, these 3 numbers are consecutive. So this could only be a 4 or a 5. So we can eliminate the 6 and the 7 right off. These two numbers have to be far enough apart, like this has to be our 3rd consecutive number. So this would have to also be a 4 or 5. And then these two are forced to be a 2 and a 6 because they have to be minimal surrounding the 3, 4, 5. This can't be a 2 because the 3 we just said for the sake of argument is the low end. And it can't be a 6 because then this couldn't be a minimal between line because 6 is too far from one of the endpoints. The best we could do would be like 3, 5, 6, 7, but then there's a gap in our between line where the 4 is supposed to go. I'm not totally satisfied with that as a general argument, so let's try to talk through that again and just use the language like low and high instead of specifically 3, 4, and 6. So if this is the low end, this is the high end, again, symmetrical just for the sake of argument. Then if this is lower than that, either it goes blue, orange, pink, or it goes blue, pink, orange. Either way. Or it goes orange, blue, pink. Either way, these two cells bound these three minimally. This has to be the lower bound because it has to be lower than this cell because this cell is the high end of its between line. This has to be the upper bound because it has to be higher than the low end of its between line. So this is the lower bound and this is an upper bound on these three cells. Now, if this is lower than that, that means that this is at least 2 lower than the upper bound. So this is at least 2 higher than that. Oh, and it just barely works. Here's an example of a scenario where it works. I think I'm wrong. So this is an example. So if this goes like 4, 5, 6, and then this is, oh, never mind. And then this is 3, and this is 7. This side is okay, but now this side is broken. So yeah, here's the problem. So like, if it goes, like if this goes pink, blue, orange in that order, in increasing order, then this has got to be pink minus 1. But that's so small, so because it goes pink, blue, orange, pink is already 2 less than orange. This has to be pink minus 1 because it's a bound. Wait, that's not the upper bound. This is the lower bound, this is the upper bound. Sorry, I had them colored backwards. So yeah, this has to be pink minus 1, which is orange minus 3, which is too low to be on this between line. So we can't go pink, blue, orange. Well, what if we go like blue or blue, pink, orange, right? Then that means this one has to be blue minus 1, but blue is already orange minus 2, so this has to be orange minus 3, which is too low to be on that between line. So what we're figuring out is that, oh, and then the final scenario is what if it goes blue, orange, pink? And the way that breaks is the upper bound has to be pink plus 2, which has to appear here, but because it goes blue, orange, pink, pink is already blue plus 2, so this has to be blue plus 3, which is too big to appear on this between line. What an interesting thing. So what all that just proved, so what we took into account is that these three are consecutive in some order, meaning these three are consecutive in some order. These two are minimal bounds on that set of 3 numbers. And because those minimal bounds have to both appear within their own between lines, we just used kind of a complex chain of reasoning to conclude that whichever one of these is high, whichever one of these is the high end, so whichever one of these is the high end of its between line, has to be lower than whichever one is the low end of its between line. So we can't do like 1, 2, it always breaks if we do like 1, 2, 3, 4, 2, 3, 5, 4, 6, or whatever. So like if this is the low end of its between line, it has to be higher than this digit, which means that what we have is like a virtual between line, actually. We have a virtual between line where one of these is a low end. Suppose it was this. And then these are higher than it. And then this is higher still. This has to be higher than that. It cannot be lower, because that's what breaks that we just demonstrated. So this is even higher, but it's the low end of its between line. So this is even higher. This is highest. So like one of these two ends here is quite low, and then the other end is quite high. So like the minimum is 1, 2, 3, 4, 5, 6, 7, 8. So that implies, because we have 1 degree of freedom there going 1 to 8, so we could go 1 to 8, we could go 1 to 9, we could go 2 to 9. So one end has to be 1 or 2, the other end has to be 8 or 9. We don't know which end is which. And then these, of course, are all 3, 4, 5, 6, or 7. I wonder if we can even do better than that and prove that it has to specifically be 1 and 9. Because, let's see, does it have to be 1 and 9? Well, what if it's 1 and 8? Does it break? Like if this is 1 and that's 8, it would have to go, if it starts with 1, the only way to do it is to go 2, 3, 4. And if it's got an 8 there, the only way to do it is to go 8, 6, 7, and 5. So these have to be either 3 and 7 or 2 and 6, meaning this is either 3 or 6. And that's all completely fine. So it could be 1 and 8, could be 2 and 9. Could it be 1 and 9? Like, does 1 and 9 break? I think actually 1 and 9 might break. So if it's 1 and 9, that would have to go 2, 3, 4. This would have to go 7, 8, 6. Oh no, that's actually completely okay too, because then that would have to be a 5. And then this pair would be a 3 and a 7. Cool. So it could be 1 and 9, could be 2 and 9, could be 1 and 8. Love it. Love it. That's so cool. Okay. Now that puts some limits on what these digits here can be, I guess, in the corners. Because like if this is 1, that's got to be a 4. If this is 2, that's got to be a 5. And vice versa, if it's 9, 8, 7, 6, and if it's 8, 7, 6, 5. So these have to be 4, 5, or 6, both of them. Now, the interesting thing is, for these to be minimal, so for these to be minimal, this has to be 4 away from whatever's here. So if this is a 5, then this is either a 1 or a 9. If it's a 4, then it's an 8. And if it's a 6, it's a 2. So these are once again 1, 2, 8, or 9. And those cells. Wow. Oh, that's just too cool. That's too cool. This is really very, very elegant. I like this quite a bit. I don't know which is which. I would love to, but I don't. Okay, what now? So, what now? And, oh, and one of these has to be 5. So it could be 3, 4, 5, 4, 5, 6, 5, 6, 7, really like in any order. And there are some restrictions on these too, I think. No, there aren't. So like this could be as low as 2, because then we could go 1, 2, 3, because those don't have to be ordered. 4, and that would be fine. I don't think these cannot be 3s, I think is the only thing, and they can't be 7s. Because if it's a 7, then even if it's twin, so if it's twin or is a 1 or if it's twin is a 1 or a 2 and it's a 7, then that's too much distance for it to be minimal. And if its twin is an 8 or a 9 and it's 7, there's not enough distance to fit 2 digits in there. So it can't be a 7, and for the symmetrical reason, it can't be a 3. So those are 4, 5, 6 as well. So these are both 4, 5, or 6. This one could theoretically be 3 or 7, or it could also be 4, 5, or 6. That's just great. That's just too cool. I guess we could pencil in what goes here too, and here. Oh, hold on a second. So actually we don't have to do that. We've got something way easier that we can do right now. So this is a 1, 2, 8, or 9. There's a 3 skyscraper clue. Well, if your first skyscraper is height 8, you're definitely not going to be able to see anything else over it except maybe the 9 skyscraper. So at most you'll get to see 2. If your first skyscraper is height 9, you know you're only going to see that one. You're not going to see anything beyond it. So this can't be 8 or 9. So this has got to be our low end, and this has got to be our high end. This could, 2, 3, 4, this has got to be 4 or 5, and this has got to be 5 or 6. So that eliminates a little bit. And this can't be a 4 anymore, and this can't be a 6 anymore. So it goes either 2, 3, 4, 5, or it goes 1, 2, 3, 4. That does mean that one of these cells contains a 3. It also means, so this one goes either 6, 7, 8, 9, or 5, 6, 7, 8. So this contains a 7. And we can copy that over, all of that, to the other clone. So that's a 4 or a 5, that's a 5 or a 6. One of these contains a 3, and one of these contains a 7. We can also now go ahead and pencil in what goes here. So this is either 1, 2, 3, 4, or 2, 3, 4, 5. So it also definitely contains a 3. Similarly, this definitely contains a 7, and it's either 5, 6, 7, 8, or 6, 7, 8, 9. So actually in this run, we know we have 6, 7, and 8. Here we know we have 2, 3, and 4. So like nothing else here can be 2, 3, or 4. Nothing else down here can be 6, 7, or 8. I bet we'll end up having to use that if I've gotten the read of this puzzle so far. Right on. Now what? Oh, and similarly, this can't be 8 because we couldn't see 3 skyscrapers if the first one was an 8. So that's just tiny elimination. That cell's not an 8. It also can't be a 7. Well, yeah, it could be a 7 because we could see both the 8 and the 9 behind it. So what next then? We need something else. So I believe that this cannot be a 2 anymore. Because if this is a 2, we'd have to have cells 3, 4, and 5, and then this one would be 3, 4, or 5, and then this would have to be a 6. So this can't be a 2. Symmetrically, this cannot be an 8, because 8 would give us 5, 6, and 7 along the line, which would mean this couldn't be a 5 or a 6. Unfortunately, I don't think... Oh, so we can also argue that this isn't a 1, because check this out. We just realized because of the clones... Oh, this is so fucking smart. This is amazing. We just realized because of the clones, 3 has to be here or here. That's pointing to this, so none of these cells can be a 3. So this, if it was a 1, we'd need 2, 3, and 4 there, because it has to be minimal, so they have to be right up against the 1. Well, we can't, because there's a pair of 3s there, so this can't have a 3. It would have to be like 2, 4, and 5 with a hole for the 3. It wouldn't be minimal. So 1 is right out there. And again, symmetrically, 9 is out there. So we can pencil those in. This is a 1 or a 2, and this is an 8 or a 9. And that means we can pencil mark in the numbers that actually go in here. So if it's a 4, then these are 5, 6, and 7, and then this is 5 or 6 or 7. If it's a 5, this is 6, 7, and 8. This is 6 or 7 or 8. Again, through symmetry, these are 2, 3, 4, or 5. Super, super, super cool. Very elegant and very, very cool. Now this is interesting. We know... Okay, let's think through this. I'm not great with skyscrapers. What stands out to me now is that this is lower than that. So no matter what you choose for these two cells, this one has got to be lower than that one. That means we see those two skyscrapers no matter what. Like you always see the first skyscraper and the second skyscraper on this row. And because neither of them can be 9, we know what our third skyscraper is that we see. It's a 9. Because you're always going to see the 9 behind this green one, because the green's not tall enough to block it off. So whatever you see, it's going to be a 9. That doesn't really tell you where the 9 is. I suppose technically it tells you that this cell can't be a 9, because if this was a 9, this would be an 8, and then you'd see both the 8 and the 9. Beyond that, though, I'm not sure that helps as much as I thought it would at first. let's hang on to that. Let's keep that in our back pocket for now. Okay, cool. So, where to next? I mean, maybe we have to tackle the skyscrapers, really. I do see a 1-2 pair here, but I'm not really sure like what it's useful for. I'm not sure if that's going to help me with anything, honestly. Um, I don't know. One of those is a 3, one of those is a 3. I don't see a lot of places that a 9 could appear here now. Like 9 can't be in any of these cells. Oh, 9 also can't be in this cell, again, because of skyscrapers, because if there was a 9 here, we would see this skyscraper. Oh, no, that could be okay, right? Because this doesn't necessarily block this one. This could be shorter than this one, and then we would have a 9 after it. So it could be there. So 9, like, can't be in any of these cells, which means 9 can't be in any of these cells. It also can't be there, there, or there. Can't be in any of these spots. I mean, 9 is really pretty limited. It can't be there because then we would only see 2 skyscrapers, not 3. Can't go there or there, meaning I can't go there. A 9 in column 9 is almost found. I mean, 9 in column 9 definitely has to be either here or here. Unfortunately, neither of those seem to really interact with other clues just yet. Oh, I just saw what I could do. I didn't do some cleanup that I should have already done. So if you look at these, now that we sussed out which one of these is going to be low, which one of them is going to be high, like this is kind of the low end, this is the high end, we can figure some stuff out about what digits have to be in the middle. So this has got to be a 6 or a 7. That actually gets very restricted. 6, 7, or 8. Wait, can't that be an 8? 6, 7, or an 8. Oh, it can't be an 8 because of the skyscraper issue. So that's got to be a 6 or a 7. So that's actually definitely a 6 or a 7. That's a 2, 3, or 4. But because it specifically has to be 4 away from whatever's here, it's got to be either 2 and 6 or 3 and 7. So that cannot be a 4. It's either a 2 or a 3. Ooh, wow, this is like really, really kind of shaking out. Okay, so that's 5, 6, 7, 8, or 6, 7, 8, 9. So this has to be either 6, 7, or 8. And this is either 1, 2, 3, 4, or 2, 3, 4, 5. So that's going to be a 2, 3, or 4. Awesome. Beautiful. Really beautiful. And we know that, again, we still know that's got to have a 7, that's got to have a 3. I don't know how I had that marked and I hadn't cleaned up my pencil marks yet, but just work with me here. So this has got to be either 4, 5, 6. It could be like 3, 4, 5. 4 or 5. Like, this is just still, like, not restrained, really. Aha. Now we can say that 9 can't be here. Finally, because this has to be greater than this, because this is the high end, and that's what I hadn't figured out yet. So this is the high end. I already knew that, I just didn't have it marked up here. It's the high end of its between line, so this first cell is greater than the second cell, which means we only see this one. So if we put a 9 here, we would only see 2 skyscrapers in total, because everything over here would be blocked. So none of these can be 9. 9 has to be either here or here. Is there anything else that we can do along those lines? Because that doesn't quite tell us like where any 9s are. We still have no digits and we're 37 minutes in, and I feel like I've made so much progress with this already. I mean, I really feel great about this puzzle. I'm really, really enjoying this. It's just very intricate without being like overwhelming. That can't be a 7 because the 7's here are pointing to it. Likewise, this cannot be a 3. This is almost a quad. And again, this is almost a quad, but almost only counts in horseshoes and hand grenades. Okay, one of those is a 7. The other one's a 6 or an 8. Where to, where to, where to? Where to, Clover? 2 and 6 or 3 and 7? Okay. Maybe skyscrapers again. I was about to say, didn't we have a third skyscraper clue? And the answer is yes, it was down here. And 9 is even more restricted. Can't go there, can't go there. Can't go there, because it has to be in one of these two cells pointing at it. Can't go anywhere here. Can't go anywhere there. Or there. Or anywhere here. Or here. Gosh, 9 can just go, like, almost nowhere. It's gotta go down here somewhere. And it's gotta go down here somewhere. Can't go there. Jeez. Wow. And because it has to go in one of these two cells, all of these are going to be blocked. So those are all cells where we can't place a 9. And that, see, there's kind of some interplay back and forth between the clones here. For instance, I know because in this clone, it has to be in one of these two cells, that there has to be a 9 in one of these two cells because it has to copy over here. But because the boxes are aligned differently between the two clones, that actually tells me that there's no 9 here because this box slightly overlaps the corner of this clone. But that comes back here, tells me there's no 9 there. I don't know if that's useful, but it is beautiful. Anywhere else where we can't place a 9? Because like I really feel like we're so close to being able to locate a digit. Just so close. Oh, here's an 8-9 pair, so we can actually cover up everything in between there. Can't be a 9. Does that imply anything? That implies that that can't be a 9, because we're copying again from the clone. Like so close, but so far. There's just not quite anything. I wonder if one of these arrangements is going to end up causing these to come out like equal to each other. Like if this is 9, or if this is 8, then this has to be a 1. So it can't go 8, 2, because we don't end up having enough space. 2, 3, 4, 5, 8, 6, 7, 5. Those would have to be the same, and they can't be. So if this is an 8, that forces a 1. And if this is a 1, that forces a 4. And if this is a 4, 4, 5, 6, 7, it forces an 8. So actually, this can't be an 8, because if it's an 8 here, we kind of loop all the way around, and we end up forcing an 8 up here. So this is our very first digit. It's a 9. I think a lot of stuff is just going to fall right out now. So that's a 9. We've got a 6. This is going to be a 2, and there's going to be no 2s here. This is going to be a 7 and an 8, and this is going to be a 3. This has to be now a 4, 5, or 6. We can copy over our 3, our 7, our 2, our 8 to the clone. Because of that clone down there, that's got to be a 6. Now these can't be 6s, those have to be 4s and 5s. That's a 3, 9, 4, 5, 6, 3, that's not a 3. So it's either 1, 2, and 3, or 2, 3, and 4, and 5. So this still could be either 4 or 5. Beautiful. Beautiful. Now, I noticed something, and again, it's something we can't use yet, but we will get to use it eventually. Because this is a 7, 6, there's a 7 as our first skyscraper looking from the right in this row. And that means we have to see both 8 and 9 behind it. I don't know where they are, but I do know that the 8's in front of the 9, because if the 8 was behind the 9, the only two skyscrapers we would see would be 7 and 9, and we wouldn't be able to see the 8. So that's kind of cool, I guess. Along this column, we're almost done. We only have 1, 2, and 9 left. These are actually 1, 2, 8, 9. These can't be 9 because we already kind of established where the 9 goes. Oh, and this is an 8 because that's a 9. Oh, and this actually is going to loop all the way back around, and because this is an 8, this is going to be forced to be a 4. So that actually had to be a 4 either way. So this goes 4, 5, 6 like that. This cannot have an 8 on it. This has to be a 2, both because of the clone and just because of Sudoku logic in this part of the puzzle at this point. And this has to be either a 1, 8, or 9. What a lovely chain of logical reasoning. This is really very, very cool. It's very intricate without feeling cluttered. I'm very, very impressed with this puzzle. That can be a 2. So we have a 2 in that column now. That resolves the 2 and the 3. I wonder if there's something symmetrical that's like going to do that down here. Maybe not yet. We'll get there. We always get there at the end. It's a 1 or an 8. This was our 8, copying over from the other clone. It's not an 8, so that's either a 1 or a 9. Copying from the clone, that's a 2. And is there anything else where we can just get something real easy by copying? 1, 2, 3, 4, 5. This is going to be a 6, 7, or 9. I'm not sure why I'm bothering to pencil mark that, but whatever, just roll with it. Oh, this has got to be a 7 because it already has a 5 and a 6 in its column, so this can't be a 7. That's got to be 5 or 6. And skyscrapers again, maybe? What else goes in this box? Knowing what's next to this 1 could help me with the skyscrapers. That's 5, 6, 7, and 9. Those are all pretty big numbers. This one can't be 9, because then we couldn't possibly see 3 skyscrapers. This can't be an 8, because there's an 8 in its column, making this an 8, making this a 1 and a 9, which is probably going to help us with what we were just thinking about, possibly. So that's not a 9. Okay. I could play with this a little bit. So this has got to be either a 1, a 3, or a 4. In fact, this whole column is close to done. It's 1, 3, 4, and 9. So that's either a 1 or a 9. That's not a 1, that's not a 1, or a 9. Here we've got it's a 1. Now what can we put in this piece of the clone? I just don't, you can see I'm trying to dodge working on the skyscrapers, just because I just don't want to. I mean, we're gonna see a 9 somewhere in here. Let's just finish off this row and figure out the skyscraper clue. So what do we have left in the row? It's 1, 6, 7, and 9. This has either got to be 1 or 6, and that's got to be 6, 7, or 9. So the 1 is in one of these 2 cells. The 9 is in one of these 2 cells. And we're definitely going to see the 9. And we're going to see one other thing in front of the 9. So we're going to see the 3, we're going to see something else, and then we're going to see the 9. But I think either arrangement is okay then. So we're not there yet. Very, very close though. That's a 3, 4, or 5. I'm just doing kind of some basic Sudoku at this point. It's a 1, 3, 4. 6 or 7, it's not 1, 2, 3, 4, 5, 6, 7, or 9. So we actually do have down this column a 5, 6, 7, 9 quad, which means our only two remaining digits are 2 and 8, which means that this has to be the 8 and this has to be the 2, which means these are 3, 4, or 5. Our 1 definitely has to be there. That gives us a 3, 4, 5 triple here, which restricts that to 6 or 7. These are in fact 1, 6, or 7, and that's a 3, 4 pair. And then that's 5, 6, 7, 9. Okay, so let's clean up a little bit. Skyscrapers. We're gonna see, oh yeah, we're gonna see the 7. We know we have to therefore see the 8 and the 9, which means that the 9 has to be behind the 8 in order to get up to 3 skyscrapers, which means that we can almost entirely resolve this box, and we can resolve a lot of this stuff over here too. Now because this is 3, we can't possibly see both of these. It can't go 3, 6, 7, 9, because then we'd see at least 4 skyscrapers. This has to go 3, 7, 6, 9, so we see the 3, the 7, and the 9. Which means that this is a 5 and this is a 6. We have a 3, 4 pair there, with the only remaining digit being a 5. Okay. Can we figure this all out? Yeah, that's all good. We see a 1, we see a 5, and then we have to see the 9 before we see anything else, because if the 9 was all the way over here, then we'd see at least 4 skyscrapers. We'd see like the 1, we'd see the 5, we'd see like either a 6 or a 7 in here somewhere, and then we'd see the 9. So that can't be the 9, that's going to be a 7. Meaning that this is all cleaned up. Awesome. And how do we just finish this off? Let's just finish it up. This has to be an 8, 9 pair. This is a 5. And that makes this a 1. We can resolve our 7, 8 pair. That's not a 5 or a 6, but we knew that. This is 1, 3, 4, 9. That's not a 3. This one additionally cannot be a 9, and that can't be a 4. And that can't be a 1. And what else? This column needs a 2, 5, 6, or 9. That's not a 2 or a 9. That's not a 2 or a 5. That's not a 6. That's not a 2 or a 6. So this is 5, 6, or 9. The only place 2 could go is there. Awesome. The only place 1 can go in this box is here. And the only place 8 can go in the row is here, making, is here. So that's 8 and 9. That simplifies that to 5. This is a 4 and a 3 and a 9, which lets us clean up this box above. And I think this clears this 1, 7 pair and the 6, 7 over here. Clears that 3, 4, 3, 4, 5, 3. I'm glad this is all resolving nicely at the end. And there we go, 5138. Good job, fritzdis. This was a really beautiful puzzle, and I really enjoyed it. I kind of suspected there was going to be something like a virtual long between line here, but I'm glad that that I went to the trouble of proving it, because I think that ended up being a really interesting finding, and I want to use that in a puzzle now. I'd like to steal that from you. So there it is. It's been thoroughly tested. I can confirm it not only solves, it's a really strong puzzle, and I think you should archive it.